Let's take a look at the Unit 3 test review and work through each problem. Number 1, it says solve x squared plus 9x plus 14 equals 0 by factoring. In order to factor, you want to make sure that your quadratic is in standard form, which is ax squared plus bx plus c equals 0. It is already in standard form, so we are ready to go ahead and factor. You want to look and see if there is a GCF, which is a number or variable that goes into all three terms. There is not, so there is no GCF. Then we want to identify A, B, and C. A is your number in front of x squared, which is 1. B is your number in front of just x, which is 9. And C is your constant, which is 14. Make sure you are very aware of your signs and you include negatives if either A, B, or C is negative. The next thing we're going to do is we are going to create our star. In the top of the star, we're going to put the value of A times C, which is 1 times 14, which would be 14. In the bottom, we're going to place the value of B, which is 9. And we are going to think about the factors of 14, so 1 and 14, and then 2 and 7. And we're going to decide which pair of those would multiply to give us 14, but add to give us 9. And that is going to be 2 and 7. So we're going to place those numbers in the top, and we are going to divide by the value of A, which is 1, creating two fractions. If those fractions simplify, you should definitely do that, but if they don't, then you are ready to create your factors. So 2 over 1 does not simplify, and neither does 7 over 1, so we are ready to write our factors by going bottoms up. So we look at the denominator, which is 1, that will be the number in front of x, and then the numerator will be the number that you add or subtract to x. So for 2 over 1, that would be 1x plus 2, which is just x plus 2. For 7 over 1, that would be 1x plus 7, or just x plus 7, and that is your factored form. Remember, x plus 2 is called a factor, and x plus 7 is also a factor. Factored form is the same thing as intercept form if you were graphing. To find the solutions, you're going to take each factor, so you're going to take that x plus 2, and you're going to set it equal to 0, and you're also going to take x plus 7 and set it equal to 0. To solve x plus 2 equals 0, you're going to subtract 2 from both sides, giving you x equals negative 2, so x equals negative 2 is one solution. To solve x plus 7 equals 0, you are going to subtract 7 from both sides, giving you x equals negative 7. So the second solution is x equals negative 7. Your solutions are also known as zeros, x-intercepts, or roots. Your solutions should have the opposite sign as your factors, and then if you're doing the star, they should be the opposite value of the fraction. So we had positive 2 over 1, but our solution became negative 2. We had positive 7 over 1, and our solution became negative 7. The same thing is true is if I give you the solutions and ask you to write the factored form, you want to make sure you do the opposite, just like we did when we were creating intercept form. Let's try another one. This time it is not in standard form. We have our ax squared and our bx on the left side, but our constant is on the right side. So we're going to need to start by subtracting 54. And you may or may not need to show this step. It's up to you and your comfort level. Make sure you put that negative 54 in the correct place. Since it's the constant, it should be at the end. 3x squared minus 9x minus 54 equals 0. The next thing you want to check for is a GCF. 3 does go into all three terms, so we're going to divide them all by 3. And when I do that, it's going to become x squared minus 3x minus 18. Remember that your GCF of 3 is a factor, greatest common factor, so it will be part of factored form. So make sure that you don't lose it as you get your factored form. Now that we've taken out those values, we've divided everything by 3, we have new values of a, b, and c. Our new value of a is 1, our new value of b is negative 3, and our new value of c is negative 18. Let's do our star. Up top, we're going to do a times c, which is 1 times negative 18, so that would be negative 18. And the bottom is negative 3, which is our b value. We're going to think about factors of 18. So we have 1 and 18, 2 and 9, 3 and 6, 4 doesn't go into it, 5 doesn't go into it, and then you're back at 6. So these are your only 3 factors of 18. So we've got to pick which one will multiply to give us negative 18 and add to give us negative 3. Because we need it to multiply to give us negative 18, we know one of them must be negative. So if I pick 3 and 6 as my 2 numbers, right now, if I put those together, that gives me positive 18 as a product and then positive 9 as a sum. So I need to make one of them negative. So I'm going to make the 6 negative. That way 3 plus negative 6 becomes negative 3. We're now going to divide them each by the a value, which is 1, and we're going to try to simplify, which they don't. So we're now ready to do bottoms up. 3 over 1 means x plus 3, and negative 6 over 1 means x minus 6. So your factored form is 3 times x plus 3 times x minus 6. Remember that it is okay to write them in the opposite order, so you could do 3 times x minus 6 times x plus 3. To get our solutions, we're going to take our factors and set them equal to 0. So I can set 3 equal to 0. If I set 3 equal to 0, that doesn't make sense, so that's not going to give me a solution. There's got to be an x involved or some sort of variable involved to give you a solution. So I'm going to take my next factor, x plus 3, and set that equal to 0. In order to solve that, I would subtract 3 from both sides, and that would give me x equals negative 3. So my first solution is negative 3. And then I'm going to take my last factor, x minus 6 equals 0, and I'm going to solve that, which means I would need to add 6 to both sides. And so x is going to be positive 6. That is my second solution. Remember that your solutions are the same thing as your zeros or your x-intercepts or your roots. They should have the opposite sign as your factors and the fractions that you set up when you did your star. Let's try one more factoring problem. This problem is 6x squared minus 11x minus 7 equals 0. It is in standard form, so we do not need to rearrange it. We'll check for a GCF. There is no number or variable that goes into all 3 terms besides 1. So we are ready to go ahead and identify A, B, and C. A is 6, B is negative 11, and C is negative 7. We're going to do our star. Up top, we're going to do A times C, which is 6 times negative 7, which would be negative 42. In the bottom will be our B value, which is negative 11. So we're going to think about our factors of negative 42. Really, we could just worry about positive 42 for right now, and then we'll deal with the negative. So we've got 1 and 42, 2 and 21. Let's see, 3 goes into it 14 times. 4 does not go into it, 5 does not go into it, 6 and 7, and then that would be the final pair. So we're looking for the pair that we can get an 11 out of. Definitely not 142, not 2 and 21. The pair is going to be 3 and 14. But in order to make that a negative 11, we're going to need to make that 14 negative. When I multiply them, I'll get the negative 42, but when I add them, I'll get negative 11. Now we're going to divide by a, which is 6, and then we are going to try to simplify these fractions. Negative 14 over 6, each of those is divisible by 2, so that's going to become negative 7/3. And 3 over 6 becomes 1/2. We're going to take our fractions and we are going to go bottoms up. So 1 over 2 becomes 2x plus 1, and negative 7 over 3 becomes 3x minus 7. You can always verify that these are correct by foiling. It's more of a mental step than, having to write it out, although you could write it out if you want, but this is the form that we want. That way, when we go to find our solutions, our x-intercepts, our zeros, our roots, whichever word we're using, that we are going to take those two factors, 2x plus 1, we're going to set that equal to 0 and solve it because now it's linear. And we're going to take 3x minus 7, and we're going to also set that equal to 0 and solve it. So for the first one, to solve that, I need to first move the constant of 1 over, so I'm going to subtract 1. That's going to give me 2x equals negative 1. And I need to get rid of the coefficient of 2, so I'm going to divide both sides by 2. Remember to leave these as fractions if they don't work out nicely, so our first solution is x equals negative 1/2. Be careful and don't write that as negative 2. For our second solution, we are going to solve 3x minus 7 equals 0, so I'm going to start by adding 7 to both sides. So 3x equals 7, and then we're going to divide both sides by 3. 3 does not go into 7. It doesn't reduce, nor should it reduce. X is equal to 7/3. And those are our two solutions, our x-intercepts, our zeros, or our roots. So in question 4 and 5, we're essentially doing the opposite of what we just did in questions 1 through 3. Here we are given the solutions, or the roots, the zeros, the x-intercepts, and we are creating the equation. So in number 4, it says create an equation in intercept form with a solution set of -4, 9. Don't confuse -4, 9 as a point. What that really means is that x is equal to -4 and x is equal to +9. Intercept form is the same thing as factored form. So we wrote that out. That is one of the forms we talked about. It is x minus p times x minus q. There's an a value in front, and you can have it y equals, you can have it equal to 0. It doesn't really matter. So we need to be careful when putting these x-intercepts in. We need to make sure that we make them the opposite. So the a value, we don't have any information to know what the a value is, so technically you could create any a value you want. I'm just going to leave it as 1. So when I substitute -4 in, it's going to become x plus 4. And when I substitute 9 in, it's going to be x minus 9. So you have to make sure that our solutions are the opposite signs as our factors. And that is intercept form or factored form, so you would be done at that point. On number 5, it's very similar, except for it says create it in standard form. So we're going to do the same thing, but then we are going to change our intercept form to standard form by foiling. So a solution of 1 will look like x minus 1, and a solution of -8 would be x plus 8. And if that is what they want, if that's the form they want, you would be done. But because this says standard form, we're going to FOIL. So we're going to distribute the x to x and the 8. So x times x is x squared. X times 8 is 8x. And then we're going to distribute the -1. So -1 times x is -x. And -1 times 8 is -8. And then the last thing that we'll need to do is to combine like terms, and I do have my outside and my inside, or my OI, need to be combined, so that is going to give me x squared, positive 8x minus x is positive 7x, and then the constant of negative 8. And these do say create an equation, so technically they should have an equal sign. So I'm just going to throw an equals 0 at the end. It could be y equals, or maybe just an expression. The key is that you know how to actually write the x plus 4 and the x minus 9, or the x minus 1 and the x plus 8. You can go from solutions or x-intercepts to factors, and then if necessary, know how to FOIL to get your standard form. For number 6, they give us a quadratic, 2x squared minus 24x plus 12 equals 0. That's in standard form. And it says it can be written into the form x minus p squared equals q, where p and q are constants, and we're trying to find the values of p and q. So we did this in the second part of the unit. This was on your Unit 3B quiz. And in order to get it into this form, we need to use a process called completing the square. And completing the square was the one that had all of those steps. So make sure that you know the steps of completing the square. So the first step to completing the square is to move the constant, which is 12, to the other side. So to do that, we are going to subtract 12 from both sides. So 2x squared minus 24x equals negative 12. Step 1 is move the constant to the other side. This is the one where you don't want it in standard form. Oops, I forgot the x on the 24. The next step is whatever a is, divide by a, because you want a just to be 1. So since a is 2, we're going to divide all of our terms by 2. If a was already 1, you could skip that step because dividing by 1 will not change anything. That is going to give us x squared minus 12x equals negative 6. If you remember, when we did this, after that step, I left space because we were going to find that number that would make the trinomial factorable. So to find that number, it's more of a mental step, or you do it off to the side. You're going to use the value of b to help you find this new number that we're going to add to both sides. So our b value is negative 12. So we're going to take negative 12. We're going to cut it in half, so divide by 2, and then we're going to square it. So that becomes negative 6 squared, which is 36, and that is going to be the number that we add to both sides. It should always be positive. On the right side, I'm just going to combine the negative 6 and the 36, which is 30. And on the left side, we're going to factor that. And we talked about a shortcut, but let's go ahead and factor it so that we can make sure we know how to do it. We just did 3 factoring problems. So if I'm looking at my star, I'm just going to do it down here. My a times c is 36. My b is negative 12. What 2 numbers multiply to give you 36, but add to give you negative 12? That's going to be negative 6 and negative 6. We're going to divide by a, which is 1. Those don't simplify, so that gives us x minus 6 times x minus 6, which is also known as x minus 6 squared. And if you look at that form right there, that is exactly the form that they wanted you to put it in. So now we can identify our p and our q. Be careful with the p, it's going to be the opposite of what it appears. So it looks like it's a negative 6, but it's actually a positive 6. The q is 30. Another way to get this negative 6 is that it will always be half of the b value. So when we did b divided by 2 in that earlier stage, it was -6. So it's going to be that same value every time. But if you don't see that, that's okay. You can use your factoring steps and you can get the same thing. We do not need to solve this. We could solve it by taking the square root of both sides and then adding the 6, but for this particular problem, all it wanted was the correct form, and we got it where it needed to be. In problem number 7, it says to solve x squared minus 5x plus 3 equals 0 using any method. So on something like this, you would get to choose what method you could use. Remember, we have 4 methods. Factoring, which does not always work, so you just want to be careful about using factoring because you don't want to spend all your time trying to factor something that is not factorable. We have the square root method. This does not work with the square root method because we would need it just to be x squared. That 5x could not be there in order to use the square root method. We could complete the square, what we just did in the last problem. That sometimes works nicely in this one because our b is 5. When we divide it by 2, we will be dealing with fractions, so I'm pretty sure most of you would want to avoid that method. But if your b was even, that may work nicely. And then the last and most reliable method is the quadratic formula because it does work every time. What I would suggest is if you're taking a multiple choice test, look at the choices. And if your choices are integers or fractions, then you know it's factorable. But if your choices all have square roots in them, then you will not be able to factor, and you should either complete the square or do the quadratic formula. So in order to do the quadratic formula, the first thing that we need to do is we need to find the discriminant. We want to make sure this is in standard form, which it is. We're going to identify A, which is 1, B is -5, and C is 3. Then we're going to do the discriminant, which is B squared minus 4AC. That's going to tell us if we even have solutions or not. So B squared would be -5 squared minus 4 times A, which is 1, times C, which is 3. You can use your calculator, you can do the math on your own, but make sure that when you put it in your calculator, you do it correctly. Don't forget the negative on the 5 and make sure you put it in parentheses. Don't forget to square the -5. When you type in -4, make sure you hit -4 and not -4. And then 1 and 3 should also be in parentheses, and that should give you 13. A discriminant of 13, any positive discriminant means that there are 2 real solutions, and so you will need to find them. If your discriminant is 0, that means you will have 1 solution and you need to find it. And if your discriminant is negative, that means there are no real solutions, and at this point in time, that's all you would say, and you would not need to find them because you do not know how to do that at this point in time. So now we're going to use our quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac, which is the discriminant. So we're just going to take that number and put it in underneath that square root all over 2 times a. So x equals, our b was -5, so the opposite is +5, plus or minus the square root of 13 all over 2 times a. A was 1, so 2 times 1 is 2. The next thing you're going to want to do is see if the square root of 13 simplifies. If we did a factor tree with 13, it is a prime number, and that means it's not going to break down. So there will be no couples to go out or singles to stay in, so it actually doesn't simplify. And if your square root doesn't simplify, then the rest of that doesn't simplify. So you're actually done at this point in time. So x equals 5 plus or minus the square root of 13 over 2. The one thing that we did talk about is you could split it into 2 fractions. So put the 5 over 2 plus or minus, and then the square root of 13 over 2. Remember that, if your test is multiple choice, the way or the format that you leave it in may not be the format that your choices are in. So you do need to know how to recognize what is equivalent to the solution that you came up with. And keep in mind, this is two solutions. One is 5 over 2 plus the square root of 13 over 2, and then the other solution is 5 over 2 minus the square root of 13 over 2. Because you've got a square root here, that means this was not factorable. So if you would have tried to factor, you would have never been able to come up with a pair of numbers that would work. So again, look at your answer choices if it's multiple choice, and if you see square roots, then I would just go straight to the quadratic formula. All right, for 8, 9, and 10, we are looking to decide if there is a maximum or a minimum, and then actually finding the maximum or minimum. So to determine if there's a maximum or minimum, you want to think about the parabola and whether it opens up or down. Any parabola that opens up will have a minimum value, and any parabola that opens down will have a maximum value. To decide if a parabola opens up or down, you want to look at the a value. So in number 8, a is equal to 1, which is positive, so that means this is going to open up, which means there is a minimum. The vertex is a minimum, so we've got a minimum. To find the minimum, the first thing we need to find is the axis of symmetry. The formula for the axis of symmetry is x equals opposite b over 2a. It's that first part of the quadratic formula. So our b value is 6, so the opposite of 6 is negative 6. And our a value is 1, so 2 times 1 is 2, so x would equal negative 3. Negative 3 is not the minimum, though. Negative 3 is when the minimum occurs, so it's the x-coordinate of the vertex. So to find the y-coordinate of the vertex, you need to plug negative 3 in to the equation for all of the x's. So we're going to do negative 3 squared plus 6 times negative 3 and plus 7, and then that will give us the minimum value. So you can use your calculator, you can do mental math, whatever works best for you. That would be 9 minus 18, which would be negative 9, and negative 9 plus 7 would give us negative 2. So our vertex is negative 3, negative 2, and so the minimum is negative 2. On number 9, our a value is negative 2. That means this parabola opens down, and if it opens down, then we have a maximum. We are going to do the exact same thing to find the maximum. We are first going to find the axis of symmetry, which is opposite b over 2a. So our b is 4. The opposite of 4 would be negative 4. 2 times a would be 2 times negative 2, so that would be negative 4. So x equals positive 1. Again, that is the x-coordinate of the vertex. That is not the actual maximum. To find the maximum, we need to plug 1 in for all of our x's. So use your calculator, whatever you're more comfortable doing, it's completely up to you. That should equal negative 7. It's negative 2 plus 4, which is positive 2, and positive 2 minus 9 is negative 7. So our maximum is negative 7. Even though it's a negative number, it's still the highest value. And finally, same type of problem. The a value for this one is 4. And if a is 4, it's a positive number, which makes it open up, which means we have a minimum value for our vertex. To find our vertex, we need to find the axis of symmetry first by using opposite b over 2a. The b value is 16, so the opposite of 16 is negative 16. Since a is 4, 2 times 4 is 8, and negative 16 divided by 8 is negative 2. That is the x-coordinate of the vertex. That is not the minimum. To find the minimum, we need to plug negative 2 in for x. So we're going to do 4 times negative 2 squared plus 16 times negative 2 plus 27. You can use your calculator or you can do the math yourself. That's going to be 16 minus 32, which is negative 16, and then negative 16 plus 27 is going to give us 11. So the minimum is 11 for this particular function. For number 11, we are looking at the graphs of three quadratic functions, also known as parabolas, and we are matching the three different forms to each graph. So our three forms are standard form, which is your ax squared plus bx plus c. So your three standard forms would be b, d, and f. That would be the form that I would look at last. The only thing that standard form gives you is your y-intercept, which you may or may not be able to see on your graph, so it might be helpful, but it might not. Then we've got vertex form, and vertex form is a times x minus h squared plus k. That gives you your vertex, so that would be a, e, and I. And then finally, factored form or intercept form gives you your x-intercepts, and that's the a times x minus p times x minus q, and that would be equations c, g, and h. So I'm going to start with vertex form. It doesn't matter which one you start with, but I would suggest vertex or intercept, and then taking vertex or intercept form and putting that into standard form. So let's just look at equation A. Based on that function, the vertex would be negative 3, negative 8. Remember, the h is always opposite, and it would open up. So we're going to look for the vertex of negative 3, negative 8, which would be the one on the far right, so the third function. For E, our vertex would be positive 3, positive 8, but it would open down, which would be our middle graph. Here's our vertex at positive 3, positive 8, and it's opening down. So I'm going to put an E here. And then hopefully by process of elimination, that means that I is the first graph, but for the first graph, the vertex should be positive 3, negative 8, and it should open up, which it does. So this first graph is function I. Now let's take a look at the intercept or factored form. So on C, remember that the x-intercepts are going to be the opposite as they appear. So when it says x plus 5, that means the x-intercept is negative 5. And when it says positive 1, the other intercept is negative 1. And this should open up. So we're looking for x-intercepts of negative 1 and negative 5, and it needs to open up, which would be the third function, or the third graph, I should say. On G, the x-intercepts will be positive 5 and 1, and it will open up. So the first and second graph both have x-intercepts of positive 1 and positive 5, but on the first graph, it opens up. So G should go to that graph. And finally, H says that it has x-intercepts of positive 5 and positive 1. However, the graph opens down because of the negative 2 in front, so that would be the middle graph. And then finally, to get our standard form, all I'm going to do is I'm going to take those intercept forms and I'm going to quickly FOIL them. So for C, I'm going to FOIL the x plus 5 times x. Well, you don't technically have to FOIL, but we'll just practice FOILing. So I'm going to do the 2 last. X times x is x squared. X times 1 is x. 5 times x is 5x. And 5 times 1 is 5. Combine like terms, I'm going to get x squared plus 6x plus 5. And then I'm going to distribute the 2. So 2x squared plus 12x plus 10. So C matches with B. And if you look at B, the function for B, the constant is 10. So our y-intercept should be 10. I can't really see the y-intercept, but you can definitely see that it is headed in the right direction. 10 would be about like right here. And then it does open up. So that one certainly seems to match that graph. All right, now I'm going to take G and I'm going to FOIL with G. So let's do that over here. G is x minus 5 times x minus 1. So I'm going to FOIL. That's going to give me x squared. X times negative 1 is negative x. Negative 5 times x is negative 5x. And negative 5 times negative 1 is positive 5. Combine like terms, x squared minus 6x plus 5. And then distribute. I'm going to get 2x squared minus 12x plus 10. So if I look at F, 2x squared minus 12x plus 10, so G and F go together. So that would put F for graph 1. On that, the y-intercept should be positive 10, which again, you can't see it exactly, but you can definitely see that it's headed in the right direction and it should be opening up, which that one is. So by default, that means that let's see, which one have I not used? D should definitely be the second graph because it is opening down, and that is the only graph that's opening down. But if we take the intercept form for H and FOIL it, we should get the correct equation. So I'm going to do x minus 5 times x minus 1. I'm going to FOIL that first. So that's x squared minus x minus 5x plus 5. Combine like terms, x squared minus 6x plus 5, and then distribute, which is going to give me negative 2x squared plus 12x minus 10. And you can see that that does match equation D. On 12, we are rewriting the vertex form, which is the y equals 2 times x minus 4 squared plus 7. We're going to rewrite it into standard form. So there are 3 steps to do that. And you have to follow order of operation. So the first thing we're going to look at is the parentheses. The parentheses are there because of the square. So the first thing we're going to do is we're going to FOIL the x minus 4 squared. So I'm going to rewrite it as 2 times x minus 4 times x minus 4 and then plus 7. So I'm going to start by FOILing. X times x is x squared. X times negative 4 is negative 4x. Then I need to go to the inside. Negative 4 times x is negative 4x. And last is negative 4 times negative 4, which is positive 16. Go ahead and combine like terms if you want. You don't have to. You can actually do the next step, but I like to go ahead and combine like terms just to clean it up a little bit. Negative 4x and negative 4x is negative 8x. Now I'm going to have to distribute the 2. So distribute A. 2 times x squared is 2x squared. 2 times negative 8x is negative 16x. 2 times 16 is positive 32. And then the last thing I'm going to do is combine the like terms of positive 32 and positive 7. So that is going to give me y equals 2x squared minus 16x plus 39. And that is your standard form. On 13 and 14, we're looking at our transformation rules and deciding how the graphs compare to a specific function. So in 13, it says describe how the function g of x equals negative 2 times x minus 1 squared compares to the function x squared. So let's first of all see how they're different. So we started with x squared. The x is right here and the square is on the outside. So how is it different? What is in there? Well, the first thing I see is I see a negative. A negative will make the function reflect over the x-axis. It makes it open down, but the transformation is a reflection over the x-axis. So reflection over x-axis. It's not writing very well. Let me try that again. Okay, so that's what the negative does. The other thing that I see in there that wasn't there before is a 2. You're multiplying by 2. When you multiply by 2, that makes something larger. So that is a vertical stretch of 2. And what that's going to do to this parabola is it's going to make it look a little bit narrower. And then the last thing that I see is that I've got this -1 right there. That impacts the vertex. Remember that that's the opposite. So that would be a +1, which would move the function to the right 1. So this is a shift to the right or a translation to the right 1. On 14, we're comparing g of x equals -1/3 x squared plus 4 to x squared plus 4. So initially, they both have an x squared, so that doesn't change. They also both have a +4, so that doesn't change. So what is new is the negative and the 1/3. So like number 13, a negative will create a reflection over the x-axis. It'll make it open down, which is a reflection over the x-axis. The 1/3, if you multiply by 1/3, what's going to happen is it's going to get smaller or wider looking. Essentially, it is a vertical compression. So the 1/3 will vertically compress the parabola. Make sure when you have a problem like this that you're comparing what you started with to what you end. So like some people might want to say that it gets moved up 4 because of the +4 at the end, but that was already in the initial function. So that isn't something new. That wasn't a change. It was already there. If you were comparing it to just x squared, then yes, you would have to talk about what the +4 does. Right, in number 15, we are matching the equations to the correct function. You can either think about it in terms of transformations, like did it reflect, did it shift up, down, left, right, but all of these functions are in vertex form, so you can also look at the vertex of it. So in equation A, the x minus 4 and plus 5, that tells you that the vertex is +4, 5, or it shifts to the right 4 and up 5. The negative in the front lets you know that it opens down. So the only graph that opens down is the first one. But if you look at the vertex of it, it does appear that it has shifted to the left 4 and up 5. So graph 1 should be A. For graph B, A is positive, so we know it opens up. Doesn't help us too much because that leaves us with both the second and third graph. But the vertex would be 4, -5, which means it would shift to the right 4 and down 5. And if you look at the third graph, it definitely went to the right and down. So the third graph should be function B. And finally, the third function, would tell us that it opens up since A is positive, and then the vertex would be -4, -5, which means it would shift to the left 4 and down 5, which would be the second graph. The next two problems, we're going to look at some graph analysis. So for domain, we're looking at left to right. Does the function go left forever? Yes, it does. Does it go right forever? Yes, it does. So your domain should be -infinity to +infinity. Remember, all quadratics that open up and down have a domain of -infinity to infinity unless you're talking about a word problem. The range is the y. Does it go down forever? It does not. The lowest is -8. So we're going to start at -8 with a bracket because it can equal -8, but it does go up forever, so that would be to infinity. Next up is increase and decrease. When doing increase and decrease, I would highly encourage you to label your left end -infinity, your right end +infinity, and then come up with the coordinates of the vertex, which would be 6, -8. And we talked about crossing off that y value because you do not use the y value when doing increase and decrease. We're going to start on the left, and if I go on the left, and I trace at -infinity, currently we are decreasing and we will continue to decrease until we hit 6. So it is decreasing from -infinity to +6. Don't say -8. Then if we continue on to go to infinity, starting at 6, we are now increasing until infinity. So it is increasing from 6 to infinity. F of 7 means you are looking for when the x coordinate equals 7. So you're going to go to the graph, you're going to go to the right 7, and then you're going to go down to the function, and you are going to find where it intersects. And this one's a little bit small. It's kind of hard for me to read it. Looks like it is -6 right there. So when x is 7, y is -6. And then finally, average rate of change from 4 to 6. You need to go to where x is 4, which is right there at the x-intercept, so 4, 0. To when x is 6, which is the vertex, which is 6, -8. You can use your formula, change in y over change in x, and do 0 minus -8 over 4 minus 6. 0 minus -8 becomes +8, 4 minus 6 is -2, and 8 divided by -2 is -4. The other thing that you can do to determine average rate of change is to count the rise over run. So if you start at 4, you would go down 8, which would be -8, and you would go over 2. So -8 over 2 is -4. You can count rise over run as long as you have a graph. For our next graph, we're essentially doing the exact same thing. Our domain, it goes left forever, so that would be -infinity. It goes right forever, which would be +infinity. For the range, it does go down forever, which is -infinity, and it does not go up forever. The highest is 9, and we put a bracket. So y can be anything less than or equal to 9. For increase, we're going to label the left end -infinity, the right end +infinity, and our vertex is 2, 9. I'm going to cross off that 9, so I'm not tempted to use it. I'm going to start at -infinity, and I'm going to trace, and I am increasing, and I will continue to increase until I get to 2. So my increase interval is -infinity to 2. Then we keep going until we reach +infinity, and we are decreasing starting at 2 to +infinity. So my decrease interval is 2 to infinity. F of 3 means when x is 3, what is y? I'm going to erase this so we can see the graph a little bit better. I'm going to go over to where x is 3, and I'm going to go up to the graph, which looks like it is at 8. So f of 3 equals 8. And then we're going to do average rate of change from 1 to 6. So we're going to start when x is equal to 1, which would be when x is 1, y is 8. And then when x is 6, y is, looks like -7. So we have 1, 8, and 6, -7. So I'm going to do y2 minus y1 over x2 minus x1, which is going to give me 15 over -5, which is -3. I can also, if I want to, count rise over run. So if I start at 1, I would count down 15, which would be -15, and then I would count over 5, and again, -15 over 5 equals -3. If 5 is subtracted from 3 times the square of an integer, the result is 14 times the integer. What is the value of the integer? So for this, we need to first set up our equation, and then once we have our equation, we need to make the decision of how we're going to solve it. So if 5 is subtracted, that means we're going to subtract 5 from 3 times the square of an integer. 3 times the square of an integer would be 3x squared. So 3x squared minus 5. The result is equal to 14 times the integer. So that would be 14x. So this is a quadratic equation. I'm going to start by getting it in standard form. To get in standard form, I'm going to subtract the 14x and move that over to the left side. Make sure that you do not try to combine it with the 3x squared or the -5, and make sure that it goes right in the middle of the 3x squared and the -5. Because we are looking for an integer, that does tell us that we should be able to factor this. So if you prefer to factor, this would be a good problem to solve by factoring. If you don't want to think about whether or not factoring is an option, then you could easily use the quadratic formula. Either is fine. It's really just your preference of what method you like to do. So I'm going to do factoring on this one. So I've got it in standard form. There is no GCF, so A is 3. B is -14, and C is -5. So I'm going to do my star. A times C is what goes up top, so that's 3 times -5, which is -15. B, which is -14, goes in the bottom. So I'm thinking about factors of 15, so that's either 1 and 15 or 3 and 5. But I need the pair that I can arrange to give me a -14, so that is going to be 1 and 15. In order to get a -15 when I multiply, I need to make one of them negative. Because I want it to be a -14 when I add, I'm going to make the 15 negative. 1 times -15 is -15, and 1 plus -15 is -14. I'm then going to divide by 3 and simplify if possible. 1 over 3 does not simplify, but -15 over 3 simplifies to -5 over 1. We are now ready to create our factors bottoms up. So for 1 over 3, that's going to give me 3x plus 1. And for -5 over 1, that's going to give me x minus 5. So these are our factors. In order to get the solutions, I'm going to set the factors equal to 0. So 3x plus 1 equals 0, and x minus 5 equals 0. To solve 3x plus 1 equals 0, I'm going to subtract 1 from both sides. That gives me 3x equals -1. And then divide both sides by 3. X gives me -1/3. Notice that is the opposite of the positive 1/3 I had as a fraction. To solve x minus 5 equals 0, I'm going to add 5 to both sides, and that gives me x equals 5. I do not have a coefficient besides 1, and so I do not need to divide, so x equals 5. Again, the question on this one says, what is the value of an integer? Integers can be positive or negative, but they need to be whole numbers, no decimals, no fractions. So although negative 1/3 is a solution to the equation, it's not a solution to this problem. The integer would be 5. On number 19, we are solving the formula a times p minus 1 squared equals m for p. That means we are going to isolate p in terms of m and a. In terms of m and a just means that when you solve, you are still going to have m and a in your equation. P is going to be isolated, but m and a will still be there. So in order to solve this, we're going to rewrite this. And you need to think about the things that you need to get rid of in order to get the p by itself. So in order to get p by itself, you need to get rid of a, you need to get rid of the minus 1, and you need to get rid of the square. And the order in which you get rid of those is very important. So for instance, a lot of students might look at that minus 1 and say, oh, well, to get rid of the minus 1, I need to add 1. And although that's true, you cannot add 1 right now because there are parentheses. And the parentheses are there because of the square. So you're going to have to get rid of the square before you can get rid of the minus 1. But we also have that a in front that we need to get rid of. And so I usually hear two things from students, either distribute the a or divide by the a. First thing, we cannot distribute a because of order of operations. Since there's that square attached to those parentheses, distributing a is not an option. And plus, if we could, that wouldn't get rid of a. So to move a to the other side, we need to do the opposite operation, which right now it's being multiplied, so the opposite is going to be divide. So I'm going to divide both sides by a, which is going to give me p minus 1 squared equals m divided by a. Again, I can't move that minus 1 until that square is gone, so now we're going to take the square root of both sides, giving us p minus 1 equals the square root of m over a. Make sure all or both m and a are underneath that square root. Now we can get rid of that negative 1 by adding 1. And there are going to be two ways to write it. The first way would be p equals the square root of m over a with a plus 1 at the end. Make sure that plus 1 is not underneath the square root. Or you could write the plus 1 first. So it would be 1 plus the square root of m over a. Make sure that the signs follow the numbers. So if that 1 was a negative, it would need to make sure that the negative stays attached to that 1. All right, our final problem, we are looking at a graph. The graph represents the following scenario. Mr. Spirito threw his computer off the roof of Milton High School after too many teachers didn't take attendance. The graph represents the height of the computer in feet as a function of time in seconds. Use the graph to answer the questions below. So we are looking at the height of the computer after each second. What is the domain of the function? So domain refers to x, and in this particular problem, x represents the time. So when we write our domain, we're going to be looking at the possible times. When we are talking about functions, especially when they're word problems, we really have to think about the values that are reasonable. I know a lot of times with a basic parabola, the domain is negative infinity to infinity, but the time can't be negative infinity to infinity. So we need to look at the graph and think about how many seconds can that computer be in the air. All right, so the fewest number of seconds is when he first throws it. And I know that looks like that's 50, but that's not the time, that's the height. The fewest number of seconds would be 0. And then when it hits the ground, that would be 3 seconds. So our domain is 0 to 3 in brackets because 0 and 3 are included. The beginning time is 0 and the end time is 3. Any value between 0 and 3, decimals, fractions, rational, irrational, but any time between 0 and 3 seconds would be part of the domain. The last part, it says determine the average rate of change from 2 seconds to 3 seconds. So you can do this visually or you can do this algebraically. I will show you both. We need to start on the graph at 2 seconds. If we go to 2 seconds, it appears that the height of the computer is 50 feet. So at 2, it's 50. And then at 3 seconds, it's when it hits the ground, so the y value is 0. So if we want to do this algebraically, we're going to do change in y over change in x. If I look at the y values, it went from 50 to 0. And if I look at the x values, it went from 2 to 3. 50 minus 0 is 50, 2 minus 3 is -1, and 50 divided by -1 is -50 feet per second. Okay, the y changed by 50 feet, the x changed by 1 second, so 50 feet per second, and it's negative because the computer is going down. The other way to do that is to count rise over run, so start at the 250 and think about how much did you rise. Well, you actually didn't rise, you fell. And be careful, don't count the blocks, look at the scale. It fell 50 feet, so it's a -50. And then how much did you run? We ran 1 second, so -50 over 1, again, -50 feet per second.